Hey guys, this is Mr. Randall. I want to give you some insight into this unit. This unit is on vectors. Some of you have seen vectors before in physics, right? So a lot of it's the same. Some of it is going to be a little bit different, but the early parts are the same. Now, of course, everybody hasn't had physics, so you may feel like this is Greek to you. It's making no sense, and I'm going to try to make some sense of it. Okay. A vector is something that talks about movement, talks about trips, it talks about going somewhere. You move with vectors. For instance, if I told you to go from my room from the front door of my classroom to the elevator, that might be a vector that is going 15 feet. And let's say that's north. I don't know north, south, east, or west, but it's going 15 feet north, okay? I could also tell you to go from my room to Coach Pierre's room. That might be going 60 feet. And if the elevator is north and Coach Pierre's room is east, right? Thing I need you to notice is that I tell you how far to go, I tell you which way to go, right? Because vectors have to have a magnitude, which tells you how much, and it has to have a direction, which tells you how many, right? Those are the two important parts. It has to have a magnitude and a direction. If I just told you 15 feet, it would not be a vector, because I didn't tell you which way to go. If I just told you go north, it's not a vector because I didn't tell you how far. I have to tell you how far, and I have to tell you which way, okay? Both of those are important. Now, the other thing that you might not have thought about, and this is the thing that the other part that's important, is that a vector has a magnitude, a vector has a direction, and it has how much, it has how many, it has which way. What it doesn't have, what a vector does not have, is a location, right? A vector describes how you move, it doesn't describe where you are. So if I told you to go from my classroom to the elevator, that vector is 15 feet north, right? But if I told you to go from the elevator to Mrs. Gaines' room, that vector is also 15 feet north. So it's the same vector. It's the same movement. So it doesn't necessarily depend on where you are and where you're going. It depends on how far you went and in what direction. So the same vector that you use to go from my classroom to the elevator is the same vector you use to go from the door of the media center to the window of the media center. It's the same vector that you use to go from the Panther towards the front door of the building. It's the same vector that you use to go from the back of the cafeteria towards 15 feet towards the front door of the cafeteria. It's the same vector you use to go from outside of the Metro Grill station to the World Market station. And I probably have them backwards, but that's okay. Okay. My point is, it doesn't have a location, it has a direction, and it has an amount. That's it. Okay. That's the first important thing that you need to know about vectors, okay? The second and the third thing that are important about vectors, I'm going to try to touch on in this video, and I may, in order to keep the length of these videos short, I may decide to stop it at that point and move on to another video where I explain a couple more things in depth. But we're going to talk about what is magnitude, okay? What do I mean when I say it has to have a magnitude and it has to have a direction? Okay. Magnitude is, like I said, how much. So I'm going to take these off because they're not as pretty anymore. Unprettified. backspace. There we go. All right. Now, I'm going to move up. Take that back off. Backspace. Going to move up and we're going to talk about magnitude. Okay. The magnitude of the vector is the size. It's how much. Magnitude does not have to be a length. Magnitude can be a length. It can be 15 feet. It can be 3 inches. It can be 8 miles. It can be a length, but it can also be other things that can be quantified. Magnitude can be a speed. It can be 500 miles per hour. It can be 27 feet per second. Okay? It can be, as long as it can be quantified. But the magnitude for each vector cannot change. Okay? If I start off going 20 feet per second with my vector, then soon as I change speeds, I change vectors. It's a new vector, right? So if I tell you to go 5 miles an hour west, and then I tell you to speed up to 15 miles an hour, I've now started a new vector. I've started a new part of the trip, okay? So vectors have one magnitude, one length, one speed, and it cannot change, okay? That's going to be important, okay? What did I do? Don't know what I did there. So that's magnitude, right? So we've talked about the fact that vectors talk about movement, okay? They have magnitude, they have direction, they don't have a location, right? And we talked about the fact that magnitude can be a length, magnitude can be a speed, as long as it stays the same. Magnitude has to be constant for a vector, okay? Then we need to talk about this thing called direction, okay? It's pretty easy if I tell you to take 5 feet to the left or go 8 feet backwards from where you're standing, okay? That makes sense if I can see you. But for the sake of this class, you will see direction in 3 different ways, which, in my opinion, get progressively a little more confusing, okay? The first way is what we've been dealing with the whole year. You'll get a direction in an angle. So let's say that we're talking about an airplane, and the airplane is going 500 miles an hour at a 16-degree angle. That is a vector. It has a magnitude, it has a direction. It has a magnitude, it has a direction. Okay, I probably set that over because I paused the tape because I had to go tell my dog to be quiet, and then I unpaused it. So if I'm drawing that vector, 500 miles an hour at a 16-degree angle, well, a 16-degree angle would be in the first quadrant. So it would look like that. This would be 16 degrees, and the magnitude would be 500. That is a vector, 500 degrees at 500 miles an hour at 16 degrees, okay? On the other hand, let's say I had a vector of, I had a boat going 150 miles an hour, but that boat is going at 283 degrees, okay? Well, it's the same thing. I start here, 283 degrees would go like that. That would be my vector. And it was, what did I say? 120, whatever it was. So there you go. There's your other vector, okay? But this is 283 degrees, 283, okay? So that's the first way that vectors are, that's the first way the direction is recorded. And that makes sense to us because those angles are angles that we've seen before. That just truly makes sense, okay? The second way Still sort of makes sense because you're still talking about angles, but it's different. Okay. And that's bearings. Okay. You will get directions, or you will get vectors that have a bearing. So let's say that we have a bearing of bearing of 123 degrees, and it has a magnitude of 8 miles per hour. Okay, at a bearing of 123 degrees. Bearings start at 0 here, and they go clockwise. So this is 123 degrees for a bearing. Okay, bearings start at the top and go clockwise. Okay. If I'm talking about an angle, if I'm talking about the angle, a direction of 123 degrees, it would look like that. So this is the same vector described, the same quantities, the same magnitude, the same angle, but one angle is a bearing, the other angle is a direction angle. Okay? Those two are going to, those two are going to be confusing, but you got to pay attention to the wording there. Okay? You can have, like I said, an angle, you can have a bearing. So that's the first two. The third one is a map bearing. So it ties together the map. And what do I mean by the map? On maps, you have north. Uh-oh, what'd I do? What did I do? What did I do? What did? On maps, you have north, you have south, you have east, you have west. Right? And because you have north, south, east, and west, it ties that together. So it might be, let's say, 123 degrees east of north. Okay? So you'd start north and go east. So you go this way 123 degrees. And that would be your bearing. That would be your vector. Or you could have it say 27 degrees north of west. So this would be 27 degrees. So they can be a little bit more confusing. So we're going to talk about all three of those, and you'll see vectors done in all three of those. What I wanted to point out was that there are three different ways that I can describe it. You have to pay attention to the words. This ends the first recording, and we will make up the rest of it shortly.